Hello students. So today we will be discussing a very important concept of laws of motion, that is horizontal motion of bodies connected through string. So I hope you can see this question. This is a diagram and mu is given. So at first we will draw the diagram. For our own understanding, we will draw the diagram first. The force given is 50 Newton. Now we can see mu is given, so we need to find the friction. So here mu is 0.8 and here mu is 0.5. So at first we will find friction for the 6 kg. So F limiting 1, limiting friction we will find. So F limiting 1, consider is at the body 1, so limiting 1. This is mu n1. I hope you know the formula of friction. So that is 0.5 into 6 into 10. 0.5 by 10, which gives us 30 Newton. Now for this body, we will find the F limiting, that is mu n2, which is 0.8 into 5 into 10, that is 40 Newton. Now what we will do initially, when you are solving this kind of questions, consider these two bodies as single body for your better understanding. So which gives 11 kg, just for your understanding. So the external force applied here is 50 Newton and the friction will be opposite to the motion of the body. The force applied in this direction, so it will be in opposite direction. So the friction here is, the total friction is 40 plus 30, that is 70 Newton. So we can clearly see, as the force is 50 Newton and the friction is 70 Newton, so there is no chance the body will move forward. The body will be stay in its own position. So the acceleration here will be 0 for both the bodies. The acceleration will be 0. Now what we will do, acceleration is 0. Now we will find the friction and the tension. So for this, we can see the friction for the first body, which came as 30 Newton. So we can write that in this direction friction will be applied. So FL1 will be 30 Newton. Now see, in order to find the tension in the string, we will do force is 50, friction is 30, so the tension will come as 20 Newton. So the tension over here will also be 20 Newton, as it is a single string, and for a single string tension remains same. Now the limiting friction for this body is 40 Newton, and we all know that friction is a self-adjustable force. So the friction for this body will become 20 Newton. Why it will become 20 Newton? In order to cancel this, the tension and the friction, in order to cancel this, it will become 20 Newton. So it will be at rest. Acceleration here is 0. For this body, acceleration will also be 0. So the acceleration in each block A is 0. Friction for this block is 30, this block is 20, and tension is 20 Newton. I hope you have understood this question. Now students, for this question, just see, for the previous question mu was given, but in this question mu is not given. So I think comparatively this will be easier to solve this problem. So how are we gonna solve this? There are 3 blocks. So at first, I will always suggest you to draw the diagram. For this, the force is 40 Newton. So at first we need to find the acceleration. So how we should find the acceleration? Just consider this 3 block is a single block, just like we did it for the previous question. Same, consider this 3 block as a single block, that is 7 kg, and the force is 14 Newton. So now in order to find the acceleration of this object, we all know F equals to mass into acceleration. So force is 14, mass is 7. So the acceleration will come as 2 meter per second square. So we have understood there is acceleration. So acceleration is asked and tension in the string is asked. So let's just consider here is T1, T1, T2 and T2. So for this body, 1 kg. Now just draw all the forces which are applying in the body, that is 14 Newton, and in the opposite direction there is T1. So if we write F minus T1 equals to M into A. So force is 14 minus T1 equals to mass is 1 and acceleration is 2. So which is T1 is 12 Newton. Now in order to find the T2, we will take this block, that is 4 kg, and there is T2. Now T2 equals to M into A. So 4 into 2, which is equals to 8 Newton. So for the first question, acceleration is asked, which is 2 meter per second square, and the tension in the string T1 is 12 and T2 is 8 Newton. In this way you can solve this kind of questions. I hope you understand this.